Assalamualaikum. Today we are going to present our final project. So this course is Math for Computing 3. So our section is 2 and my group is G. So I am Hassan Tanvir Mahmoud and my matric number is 1725413 and my partner is Billah Said Mashkur. His matric number is 1723387. So first of all, introduction. So COVID-19 was first discovered in human body on 13 December 2019 in Wuhan City, China. So COVID-19 is an epidemic disease in the world. On 11th March 2020, who declared COVID-19 as a pandemic. So in this project, we are trying to explore the effects of the virus and trying to make a prediction by using real data set. The data is still inefficient, so we just try to get the result by asking some questions, analyzing the symptoms, and making predictions from the real data. In this project, we use the game theory to find the expected outcomes, and the reproductions of COVID-19 is very strong during the reproduction process. In human body, it can change the RNA. So it's difficult to invent a new vaccines which can destroy the chain of reproductions. So now I am talking about the stage of transmissions. So in these sections, there are five things we discuss. So first stage is imported case. So in imported case, we just discuss about the imported case first, how USA, the first person got COVID-19 virus in USA and local transmission. So we discuss about the local transmission in our reports. So for community transmission, we also declared. So epidemic and recovery, that's all. So now next slide. So methodology. So on this project, we are trying to do our analysis by using real data sets. So we collect our data from different online dataset sources. Moreover, this dataset can give more or less accuracy to analyze the real outcomes. To avoid the less accuracy, we endeavor to collect more data. In that case, we collect our data from different sources like Wikipedia, WHO's, and many things. I just create the links in the report. So this is our descriptive statistics. So Malaysia first COVID-19 case discovered at 23 January 2020. So from this graph we can see the from 50 days is just normal 1 or 0 cases, but after 50 it rising high, and after 50 to 80 is rise significantly, and after 100 days to 130 days is fluctuated. So after 150 days it's like as normal as before. So for the Bangladesh, the first COVID-19 case was discovered at 8 March 2020. So from the dataset we can see, so after 29th days it increasing gradually. So that's all from my analysis. So the rest will analyze Brother Mashkur.
Okay, so my name is Billah Said Mashkur. My matric number is 1723387. So this is the line graph for Thailand and USA according to the number of cases versus their day. And if you look at the Thailand, then we can see that Thailand, it's the first day the coronavirus was detected was on 11th January for Thailand, and for USA it was 21st January. So if we compare these two, then we can see that in Thailand there was a massive increase on the 61st day of the coronavirus. So it was about 180 to 200 cases in that day, in that one day, and it gradually went down slowly. So on its 111th day it just went down and the conditions were fine. So there was not so serious cases for too many days in Thailand. But unlikely in USA, we can see that on the 50th day it rose so high to a maximum of 4,000 and something cases per day, and then it just continued that same rate till the end. So if we look at the USA, we can see that USA has more worst case than the other countries. So that's why we took USA as the worst case, and we started to analyze uh, the calculations and predictions for the USA only. Now, if you look at the graphs and charts, then by gender, if you look at the charts by gender, then for USA, Bangladesh, and Thailand, all of them has more infected on male. So the male category has more infections compared to the female for these three countries. And on the age side, the COVID-19 cases by age for USA, we can see that about 48% of the infections are done for the people more than 75 plus years old. And for Bangladesh, the people who are more than 21 years old till 50 years old, they have got more diseases than the other categories of ages. And on Thailand, if you look at Thailand, then we can see that same. That means starting from 21 years old till 40 years old, on this category, on this range, the people have had more infections than the other category of ages. So now let's move on to the active cases in the United States, as we're talking about, as we're gonna analyze on United States. That's why we're gonna see and look at the active cases in the United States. So we know that the first case was detected on 21st January for USA. So then it started to grow from March 18th, and it started to rise, and gradually it increased to the highest. So that's why USA has the worst case scenario of infections of coronavirus. That's why we are going to analyze it. Next part will be explained by Brother Tanvir.
So we use actually R language to analyze our data. So let's move to the main controller R. So in this section it is data reading and cleaning. So in this section I just import the CSV file which I collect from internet, and hence the data is already in the controller. So I just rename the data with date, day, number, and total. So in these sections I just reformat the date, so that I can analyze easily to see the first six data. So this is the header for showing the six data, because in this part I just want to see the first six column to check is that file can readable or not. So now let's move to the data inference. Actually, as we know, COVID-19 started to be recorded in 20th January 2020. So we want to ask question and answer depending on this data set. Is there any relationship between the data passed and the number of new cases? So second is what happened after 1 week or 1 month. This includes a simple linear regression relationship between one responses, number of new cases in a given past day, and one variable or predictor, the number of day passed. That means from the dataset 20th January 2020, a user would give the number of days passed. After this day, the model should figure out the number of new cases after these days. So now I just create a new model here. So new model, just run the new model. So building the new model, we need the number of cases based on each day. So according to formula of linear regression, our targeted attribute is number of cases. Then this is our model. So I just run this model. So using linear regression, we find the estimated STD error and the intercept and the value of intercept of the days. So from there we can get the formula prediction number of cases. So this is our estimated STD intercept, and this is the value of intercept day. So we just estimated value of intercept plus we just plus the estimated intercept value, and then we multiply the day pass into the day of intercept. So for example, let's say that we want to predict the number of new cases 90 days starting from the date 20th January 2020. So we got our predictor number. Uh, so we got our predictor number here 21997.75. So this number we got from our model. Now let's check the actual value of the number of the date. So let's, for example, the last day in our data set we can check from the real data set with 100 days. So this is the 100 days. So we can see is the similar how we predict our main data set. For our prediction, we use the same formula as before. Our prediction value for the days 169 to 199. So we just which is 30 days. So we use the same formula here. So now let's run to this program. It's run already. So after checking with the actual number, we will find out that they are close to each other. Going back to our model, we can notice the following. So our RSE equals to 8538. So 858, that means we can make a prediction mistake about 8538 up or down in average. So our RS score was our R score was 0.6985. So we can see that our explain almost 70% accurate, so which is pretty good percentage. So both intercept and the day variable have a significant relationship with the responses because they both have a p-value smaller than 0.05. The p-value for f statistics is quite small, indicating that the relationship is pretty strong. So we can see that the mode has an obvious non-linearity issue, and we want to overcome this problem. So maybe we can try transmission of the predictor. So from the visualization, we can see that the model has an obvious non-linearity issue, and we want to overcome this problem. So maybe we can try transformation of predictor. So now we are going to try using the multiple of days attribute. So let's try. So now I'm going to find the summary of our second model. So our second model, the estimated STD is equals to minus 4.509, which is quite similar. So now our RSE is 4389, which is before 8538, and our now R square is 0.9224, which is before 0.6975. So we can see the difference. We got in R square and RSE is pretty huge. Let's see the graph. So from the graph, all radial are from the graph. The three graphs are similar, but the fourth one, all the radials are at a clustered form. So that's the difference. So now we can see that we can overcome our problem of non-linearity. So overall, our inference shows that the number of new cases can be represented by the number of days passed from a certain date. So that's all from my side.
So now here my work is to explain the S.I.R model for USA. So according to the data of USA, we use the R language to find the S.I.R model. So let's go to the code. So this is the S.I.R model code. So for the S.I.R, we know that S is the number of people who can get the disease. and I is the number of people who have the disease already and can transmit it, and R is the number of people who recovered, so they can also get the disease. So since there is no absolute recovery for this disease, it means that if someone get the disease and recovered from it, then it can get it again. So he can get it again. This leads us to S.I.R model, because the R is temporary and it may change. That's why we will count it as an S.I.R model. The numbers can be calculated by multiplying them by a specific rate of change from S to I and from I to S. These two rates needed to be calculated. However, the rate of going from I to S is already known. Okay, so how we get that? We get that by the disease course, which is 14 days, because according to WHO organization, the disease course is given 14 days. So that means the rate for going from I to S is going to be 1 by 14. So now the problem is to calculate the rate of S to I only, because the I to S is already given. And now here we are suggesting one way to do so. We are going to see how the number of cases is changing from day to day and get most repeated ratio of changing from day to day. So first of all, for getting the ratio, we are gonna clean the data first. So we are gonna clean the database of the US for the null values. So for here, if you go to the main value, the values which are here NA, we'll remove those by cleaning the data, and then we also remove the values which are 0. Okay, so here we can see the values are 0, so we are also going to remove those, and then we can get the CUSNU data. And after getting this, we also create a duplicate data of CUSNU past, and we will just create as same as the CUSNU except the first row of this database. So for getting the ratio, we will just divide the CSNU past table by the CSNU. So by dividing this, we will get the ratio for each row of this database. So make sure we are getting the ratio for each row, each data. Okay, so now by doing that, we can get all these ratios, and if we want to visualize this, then we get, or we want to plot this, then we get all these ratios here on this visualization. You can see, and here we can see a scalar cluster or a group of dots here. So we want to get the average, the mean ratio. Okay, so here after getting the mean ratio, we will also get the error rate by putting the ratio on it, and then we will get the left range and right range. Okay, so left and right here means the range of the transmission rate. So we know that for getting the transmission rate, we need to find the error rate. So we found the error rate already, and we already found the mean, the average of the ratio. So now for getting the minimum range of the transmission rate, we will use the formula, which is m minus error rate. So m is the mean, the average ratio minus the error rate. Then we will get the minimum range. And for getting the maximum range of the transmission rate, we will just plus those two. We will just plus the average of ratio with the error rate. Then we will get the maximum range of the transmission rate. So by printing this, we can get the transmission rate in USA, which is starting from 1.071 to 1.3427. So this will be the transmission rate for USA. So to sum up from our analysis, we can say that our calculation is pretty much accurate. We can say that the transmission rate in USA can be between 1.07 to 1.34, and although this is not 100% accuracy of our prediction, but for our analysis we just give a concept. So this will help people to be safe, to maintain a healthy lifestyle in the future. So it will make them more cautious. So that's all from us. Thank you. Hope you liked our project. This is me and Tanvir signing off. Assalamu alaikum.